Hey guys, I'm going to split this up into 4 videos. So I'm going to do number 1 through Unit 10 derivatives review packet in this video. Then I'm going to do 15 through 18 in the next, and then 19 through the end on the last page. So let's number 1. We wanted to find the derivative of each of the following functions. So number 1, the function is 4x to the 7th minus x to the 4th plus 8x squared minus x minus 10. Well, notice it's a bunch of little terms added together, and each of the terms has a power, is raised to a power, so we can use our power rule. Whenever we start taking the derivative, we want to make sure we put f prime of x or y prime if it was y equals. The power rule says multiply by the exponent, so we're pulling it down. We're multiplying it by the coefficient. It's going to become a 28, and then the power goes down by 1, so it's going to be x to the 6th. This is going to come down. The power decreases by 1. We're going to multiply by 2. The power goes down by 1. There's an exponent of 1, so it's really just minus 1x, but x goes to the 0, so just minus 1. Whenever you had just x, something x, it just becomes the coefficient. And then whenever we have a constant, the derivative of so if we were just doing negative 10, y equals negative 10 would be a straight line. A straight line has a slope of 0, so the derivative of a constant is just 0. This is my final answer. Number 2. Okay, you'll notice that I have a function, or I have a term divided by another. I'm just going to call it a function. It's a quotient rule. I want to find my derivative. This is where I do my down, d up. The derivative of the top is going to be, we're going to multiply by the 2 by the coefficient, so 6, and take down the power by 1, so down, d up, minus up. The derivative of down here is going to be 4, and this is going to be 0, so just 4. So down, d up, minus up, d down, over down, down. Down, down is going to be 4x minus 3 all squared. You don't need to FOIL that out. You can just leave that. So let's rewrite this again. So f prime of x is equal to, that's going to give me 24x squared minus 18x minus 12x squared all over 4x minus 3 squared. So my final answer is going to be 12x squared minus 18x over 4x minus 3 squared. Let's keep going. Number 3. Our function is the cube root of x squared minus 4x. Well, let's start by rewriting what this really is. I see this more as x squared minus 4x all raised to the 1/3. Remember, the cube root is 1/3 as our exponent. Well, I see now something raised to the 1/3. This is going to be a chain rule because it's not just x to the 1/3, it's something to the 1/3. So if I take the derivative, I take the derivative of the outside. So the outside, the 1/3 drops down. I subtract this, or take 1 away from this, or decrease it by 1, so it's going to be to the minus 2/3. And then I have to plug in the stuff. Well, when I plug in the stuff, I now need to multiply by the derivative of the stuff. Well, the derivative of this stuff is going to be 2x minus 4. Okay? So now we're going to want to rearrange this a little bit. So this 3 needs to go in the denominator. This stays in the numerator. This is to the negative power, so this term needs to go into the denominator. I would accept that as a final answer. I would also accept this. Number 2/3 says square this, but also take the cube root of it. Okay, number 4. My function is 1 over x squared minus 3x to the 4th plus 6x to the 5th. I'm going to rewrite this as x to the negative 2 minus 3x to the 4th plus 6x to the 5th. I don't really want to do a quotient rule here. Since I have a 1 in the numerator, let's just rewrite this as x to the negative 2. My derivative, we're just going to do the power rule 3 times. So I'm going to take down a negative 2. I have an x to the negative 3 minus 12x to the 3rd plus 30x to the 4th. Notice when negative 2 and I decreases by 1, this became negative 3, right? So I'm just going to rewrite this very quickly because we don't want any negative exponents. We're going to have a negative 2 over x cubed minus 12x cubed plus 30x to the 4th. Number 5. My function is x to the 4th, 2x minus 1. Now you could do this a couple different ways. You could do the product rule, or I am going to choose to FOIL it out first. I'm going to have 2x to the 5th minus x to the 4th. This makes it a pretty easy problem. So my derivative, notice each time, as soon as I start taking the derivative, I write f prime of x. We want to make sure it's very clear to whoever's reading that we're talking about the derivative now, not the original function. It is derivative of this function, because notice it's still f, it's still that function, but we're taking the derivative of this function f of x. So this literally means the derivative of f of x. So we're going to drop the 5, so we're going to become a 10x to the 4th minus 4x cubed. I can't tell if I'm going to have room for this next one. We will try on this page. Number 6. My original function is the quantity 4x squared plus x minus 6 times 3x minus 4 all squared. Notice I have 2 parts multiplied together. So I'm actually going to take out my red pen now. I'm going to call this g of x. I'm going to call this h of x. And notice these 2 things are being multiplied together. That means I need to do the product rule. So my derivative is going to be the first function times the derivative of the second plus the second times the derivative of the first. So let's do that. I want the first function, so all of this, times the derivative of this. Now notice this is going to be a chain rule here because it's something squared. It's not just x squared, it's a new function squared. Okay, so drop the 2 of my stuff raised to the first power. Since I plugged in stuff, I now have to take the derivative of the stuff. The derivative of the stuff is 3 plus the second times the derivative of the first. That's going to give me an 8x plus 1. Okay? Let's see if we can make this a little prettier. I've got this 2 and this 3. Sorry guys, 1 second. I feel like I wrote something down wrong. No, I think I'm good. Sorry guys. Okay, let's combine these. So up top I've got 6 times 3x minus 4, 4x squared plus x minus 6, plus 8x plus 1, 3x minus 4 all squared. Okay, now you might write these a couple of different ways. You could combine this and make this a little bit nicer. Like notice both of these have a 3x minus 4, or you can multiply this throughout by 6. There's some things to do, but I'm more than happy for now if you can leave it like that. Okay, so let's go on to number 7. Number 7. Okay, the original function is x plus 5 to the 4th and x squared minus 2 cubed. Again, I have 2 parts being multiplied by each other. So here's the first part, here's the second part. So I'm going to have to do a product rule. So I'm going to take the first one times the derivative of the second. It's going to be a chain rule, so I drop the 3, I plug in stuff, raised to the second. Now I have to multiply by the derivative of stuff, which is 2x, plus the second times the derivative of the first. Drop the 4, plug in stuff to the third. Now I have to multiply by the derivative of stuff, which is 1. So now let's see if we can make this a little bit nicer. I've got a 3 and a 2x. That's going to give me a 6x plus 4 okay. You can leave it just like that. Okay, let's keep going. Number 8. My original function is x minus 1 over x plus 3 all to the third. So notice I have stuff raised to the third. So if I want to take the derivative, I have stuff raised to the third. So I'm going to drop the 3, plug in stuff. Stuff gets raised to the second, but now I need to take the derivative of stuff. Well, the derivative of stuff is going to be a quotient rule. So I'm going to have down d up. Well, the derivative of up is just 1, right? Because the derivative of x is 1. So down times 1, we just leave it, minus up d down. The derivative of down is, again, 1 over down, down. Let's make this a little nicer. I would actually just kind of leave it like this. So minus x, we're going to have a 3 minus a minus 1, which give me a 4. I don't love that. We can make that nicer just because the denominators would be pretty easy to combine, I think. Oh, wait a minute. Yeah, so if you think about it, this is all of this squared. If you left it like this, we'd be fine, but if you squared this, you square the top, square the denominator, I'd have an x plus 3 squared down here, so on the bottom you'd have an x plus 3 all to the 4th power. I'll write that out real fast. In the numerator, you're going to have x plus 1 squared times 4. Sorry, x minus 1 over x plus 3 all squared, and it's also squared here. We're going to have an x plus 3 to the 4th, and I can actually go one step further. I think this is a pretty reasonable place you could get. So why don't we say, when you have a common factor, try to combine them. Okay. Let's keep going. Number 9. We have 2x plus 1 raised to the 2/3. I see stuff raised to the 2/3. It's going to be a chain rule. So bring down the 2/3, plug in the stuff, subtract 1, times the derivative of the inside. The derivative of the inside is just 2. Looks like we're going to need a fraction because I have a negative exponent, and there's that 3. So 2 times 2 in my numerator is going to be 4. We're going to have that 3, and then we're going to have a 2x plus 1 to the 1/3, or you could write that as a cube root. Doesn't matter to me. Number 10. My function is sine of 4x squared. So for my derivative, we're going to take the outer function, which is sine. The derivative of the outer function is cosine. We're going to plug in stuff. Now we have to multiply by the derivative of stuff. Well, the derivative of this stuff is going to be 8x. And now we're just going to rewrite this. Number 11. My original function is sine squared x plus cosine of x. This is really the same thing as sine of x all squared plus cosine of x. So if I want to take the derivative, I'm going to take the derivative of this first part. I have something squared. Now I have to multiply by the inside, because remember, this is really sine of x raised to the first power. The derivative of sine of x is cosine of x. This is a chain rule. Okay, now I'm going to do the derivative of this side, which is going to be minus sine x. You could factor or rewrite this a couple of different ways. I'll give you a couple examples. I would accept this. Or this. And I'm going to guess that some of you remembered, but I believe this thing right here might be one of our identities. I feel like this is like sine of 2x or something, but we'll just leave it like that. Okay? Number 12. The function is 2x plus 1 over x squared minus 1. This is going to be a quotient rule. I'm going to take down, d up, minus up, d down, over, down, down. Let's rewrite this just a little bit. We're going to have a 2x squared minus 2. This is going to be a 4x squared, so minus 4x squared. This is going to be a 2x, so minus 2x over stuff. So our final answer, we'll combine some like terms. So minus 2x squared minus 2x minus 2 over down, down. Okay, let's keep going. 2 more for this section. Number 13. Here's my original function. Oh, this is going to be fun. Okay, in my opinion, the best thing to do is just do the quotient rule with the chain rule inside of it. So here we go. We have down, d up. Well, the derivative of up is going to be a chain rule. So drop the 3, subtract 1. Now multiply by the derivative of the inside. So we did down, d up, minus up, d down. So that's going to give us, drop the 2, 3x plus 2 raised to the first power.